Good morning, students. Today we are going to see the last lesson in the physics, but it's very important lesson, nuclear physics. What is nuclear physics? The word nuclear says the nucleus which we studied in an atom. Atom consists of proton, electron and nuclear. We are going to study about an actions of nucleus in an heaviest atom. So this lesson is called as nuclear physics. Learning object, the first one is radioactivity. Radiations coming from the nucleus is called as radioactivity. The uses of radiation is much in science. So they are the scientists rendered make the nucleus to emit the radiations, that is called as artificial radioactivity. The emission rays consist of different types of particles such as alpha, beta and gamma. Alpha means positive particles, beta means negative particles, gamma means chargeless particles. Soddy and Fagen's displacement law, based upon the disintegration is nothing but nucleus emitting, so that is disintegrating, that is decaying by themselves. Nuclear fission and fusion. Fission is an process which used to make an atom bomb. Fusion is a process which used to make an hydrogen bomb, not a bomb which you are going to use in your Diwali. This is an nuclear bomb. Fissionable materials. The elements which have an heaviest nuclei will be fission, that is splitting into two or three, is called as fissionable material. Control chain reaction and uncontrolled chain reaction. If you are able to control the fissionable reaction, that is called as control chain reaction, that is activated in nuclear reactor Kalpakam, and energy is converted into electrical energy, nuclear energy into electrical energy. Uncontrolled chain reaction gives a devastating effect such as atom bomb. The principle of atom bomb and hydrogen bomb, based upon the nuclear fission and fusion, we are going to see that. List the uses of radioactivity. The radiations coming from this nucleus make us to diagnose our body and internal organs. Understand the components of nuclear reactor. The nuclear reactor components, how it works, we are going to study. Identify the precautionary measures while handling a radioactive material. That is, in Kalpakam, the people, those who are working, should have some measures, should have some methods and precautionary to handle such radiations. Then, introduction. Humans, as we are humans, we are very much interested in knowing about the new things or an unknown things, which something is special in that. If you know that, we want, our mind will be querying that what is there. In such a way, we are interested in atom. Things around us are made up of atom. Everything, whatever be the matter, that is made up of atom. A Greek philosopher Democritus in 400 BC believed that matter is made up of tiny indestructible unit called atoms. Later on, the elements, subatomic particles, were discovered in 1803. John Dalton said atoms are identical in nature. Thomson discovered cathode rays. Rays means particles, smallest particles that will move in a very fast manner in a line, is called as rays, which has an negative charge. So cathode rays consist of electrons. Experimentally, and Goldstein discovered the positive rays, proton particles, as electrons moving in a very fast manner is called as cathode ray. When positive particles moving in a very fast manner, that is called as positive ray, which were named as protons. Rutherford in 1932 and James Chadwick discovered an invention as a slightly different meaning. Invention, newly invented, discovered, already existed, is explained in a different manner, or some other thing is called as discovered. The charged particles called neutrons. Already neutron was found out. So he is going to say something about a neutron, so it is called as discovered. It's a chargeless particles. Presently, a large number of elementary particles, except proton, electron, and neutron, some other very small particles are there in a atom. Such a things are called as photon, meson, positron, and neutrino. These are very small massless particles, we can say, very less mass particles. These are all called as elementary particles. What do you mean by elementary? A, B, C, D. In elementary classes we have started very small, in a very small age, very starting thing is called as elementary particles. Ernest Rutherford explained that the mass of an atom is concentrated in its central part called nucleus, because electrons are comparatively less mass than proton and nucleus. So the proton is heavier mass than electron, neutron also heavier than electron. So these two things are concentrated at the center. So he said the mass of an atom is concentrated at the central part called as nucleus. You have already learnt about the atom structure in the earlier classes, in your lower class. Radioactivity. What do you mean by radioactivity? See, at the bottom of the paragraph, photographic radioactivity. This phenomena was called as radioactivity. What phenomena is called as radioactive? When a scientist kept some uranium element in his drawer when he is researching, already the drawer consists of some photographic plate. The uranium element is continuously discharging or emitting the radiations. These radiations affected the photographic plate. So emission of radiation from an heavier element, that phenomena is called as radioactivity. Later on, Marie Curie, and this thing was done by the Henry Becquerel. Then later on, Marie Curie and Pierre Curie detected the radioactivity ore, pitch blende ore. What do you mean by an ore? It consists of some metal or an element along with some other thing is called as your ore. Tiny black substance. They are surprised this is also producing some radiations emissions, and they later on find it out as ore of uranium. Then they discover radiation was more intensive from pure uranium. It was found that the pitch blende has less concentration because it is combined with some other material. After separating the new substance, they discovered it had unknown chemical properties, and it is called emitted radiation spontaneously like uranium. They named this like uranium, some element they found out. This is also emitting radiations like uranium, so they named it as radium. The radioactive elements emit harmful radioactive radiation like alpha, beta, and gamma rays. The nucleus of some elements is unstable. For example, if you dumped more and more on your stomach, you feel like vomiting. In the same way, the massful element, the nucleus alone, will be having a mass greater than 82, 92. Such elements will emit the particles outside spontaneously. Such a thing is called as radioactivity. So by emitting some particles outside, that's the nucleus will be stable. Such nuclei undergo nuclear decay and get converted into more stable nuclei. During this nuclear reaction, these nuclei emitted harmful radiation and elementary particles. Just now we seen that elementary particles, alpha, beta, photons, neutrino, like that. With the emission of radiation like alpha, beta, and gamma is called as radioactivity. Then in this paragraph we have studied what is radioactivity. Then the next one, natural and artificial. Natural means spontaneously it will emitting this. Artificial means man make the things to be done, is called as artificial. The elements such as uranium and radium undergoes radioactivity and emit radiation by their own, is called as the spontaneous emission of radiation from certain elements on their own is called as natural radioactivity. You can mark this. The elements whose atomic number is more than 83 undergoes spontaneous emission. For that they gave some examples. Uranium, radium, identified such as atomic number less than 83. They are technetium, atomic number 43, and promethium 61. Then artificial radioactivity, the phenomena by which even a light elements are made radioactivity by artificial or induced method is called as artificial radioactivity. Then when the nuclei is splitting into 2 or 3, or by emitting, the nucleus mass of the atom will be changed, so they will be converted into some other atom. That atom is called as daughter nuclei. That atom is called as daughter nuclei. For example, if a element is emitting alpha particles, I told us alpha is just like a proton. Proton means it will be losing its mass, isn't it? So then it will be converted into some other nuclei emitting unnatural radioactivity phenomena. This also results in the emission of invisible radiation. During such disintegration of nucleus, which undergoes disintegration called parent nuclei, and that newly formed nuclei is called as daughter nuclei. Here the difference between natural and artificial radioactivity is given. It's a very important and very easier thing. Very important and very easier thing you can learn by yourself. So by today we are studied 3 questions: radioactivity, natural radioactivity, and artificial radioactivity, and difference between them. Spontaneous emission, man-made, alpha, beta, gamma is emitted, and elementary particles are emitted. Exhibit by the elements with atomic number more than 83, less than 83. Cannot be controlled, can be controlled. Okay. Today up to this is okay, I think, because I told about I'm going to say about something about practicals and your 5th lesson question answers, and this you just write and send the test which I mentioned now in the audio.